So hi, my name is Sean Carolan, and I'm a solutions engineer with HashiCorp. And welcome to the Beginner's Guide to Terraform on Azure. We'll have you provisioning your first application on Azure in less than 15 minutes. If you're new to Terraform or Azure, this webinar is for you. And if you're a Terraform veteran, you might want to stick around. Perhaps you'll learn a few new tricks. So learning a new skill can be kind of scary and weird. It's often hard to take that first step, and especially if you're not a programmer, things like infrastructure as code could feel a little intimidating. Don't let that stop you. Terraform is not like learning C or Java. You definitely don't need to be a software developer to take advantage of Terraform. Our goal today is to equip you with some basic skills and to get you started on your infrastructure as code journey. Once you've got some basic skills, this gets a lot easier. It's like learning any new language. The key is to get started with the basics and practice. So what is Microsoft Azure? The dictionary defines Azure as bright blue in color, like a cloudless sky. So you can just imagine you're a majestic eagle soaring above the clouds. Microsoft's got great marketing, don't they? And what can you build in Azure? Well, the answer is just about anything. The beauty of the cloud is that it allows organizations and companies to rent their infrastructure. Traditionally, if you wanted to run an application, you'd either need to build your own data center or lease some space from someone else, your data center provider. And you could then buy a bunch of servers, install your operating systems and applications on them, and then configure your application for use. And that could take anywhere from 6 months, 6 weeks, at least several days to stand up new infrastructure. Most companies really don't want to be in the business of running data centers anymore. And guess what? Microsoft happens to be really good at this. They have a ton of experience and huge teams of people to help maintain the hardware and network connectivity that you need, so you could simply rent your resources by the hour or even by the minute. So there's some economies of scale that go on here. When you have just one user in a data center, well, they're going to use maybe 2% or 5% of the capacity. Whereas if you could get a bunch of users sharing the same pool of hardware, now you could get a lot more efficiency and lower your costs. So cloud can be very cost effective if you do it right. And it's pay as you go. So imagine I had some faucets labeled compute, network, and storage. You could turn the faucet on when you need more compute and then just turn it off when you're not using it. If you've never used Terraform, here's an example of what it looks like. Terraform is a tool. It's also a language. So that language is called HashiCorp Config Language, or HCL. And this is infrastructure as code. Instead of building things manually or creating a VM and configuring it by hand, we define everything as code in this simple language. So it's executable documentation. This is human and machine readable. It's pretty easy to learn, and it's very effective, and it works on all major cloud providers. So let's do a live demo. We're going to walk through the process of building a very simple application in Azure. First, we'll go through the Azure portal, see how you might deploy a virtual machine manually. Then we'll take a peek at the Azure Resource Manager template, and finally deploy our application using Terraform. Just going to hop over to Zoom. Okay, I see one thing in the chat here. Okay, yes, thank you. All right. So here we are in the Azure portal. Let me go to my home page here, or my dashboard rather. If you don't have an account yet, you can sign up for free. Microsoft will actually give you $200 worth, US dollars worth of Azure credits to use in your first 30 days. Or you can sign up for the Visual Studio Dev Essentials subscription, and then you get $25 a month to use. So even if your company doesn't have an Azure subscription, you could still do this on your own on the free tier. Now, once you've signed in, you'll see your landing page in the portal. One of the things I like about Azure is the ability to have custom dashboards that show different types of resources depending on what's important to you. This is my Terraform dashboard. Over here on the left side is the main navigation menu where I can view or build different types of cloud resources. So let's say I wanted to build a new virtual machine. I can click on this little plus symbol here and then select from the huge menu of different things that you can build. So if you want to build a Windows 2016 server, you click this, answer a bunch of questions in the wizard, and out pops a VM. Easy, right? You might be thinking to yourself at this point, why do I need code? Why do I need Terraform when I already have this handy GUI here? Well, let's talk about complexity a bit. The Azure UI has actually hidden away most of the complexity that's actually required to stand up this VM. This is a graph of all of the different parts that have to be configured to get my single VM running. So as you can see, there are a lot of different moving parts that go into this to actually get your VM working and running. Those are all hidden away when you use the GUI. So when you're using the portal to stand up one or even a handful of machines, what if you need to create dozens or hundreds of machines? Or what if you have to build a complex application stack that contains multiple different platforms and components? Going through the UI over and over, hoping I won't make any mistakes, not an ideal way to accomplish this task. The lesson here is that manual processes quickly become burdensome the more complex my infrastructure needs are. Okay, fine. What about ARM templates? You may have heard of Azure Resource Manager. So ARM templates are defined in JSON, or JavaScript object notation. This is an example that I just pulled from the Quick Start library. JSON is the de facto language of APIs. When computers need to talk to one another across the network, they often use JSON formatted data, just like you see here. JSON is great for computers, but not so friendly to humans. And let me show you what I mean by that. We're going to play a little game called Fun with JSON. And this also works with AWS and GCP, by the way. Here's an example of our ARM template. As you can see, there are lots of commas and curly braces here. And these are all required so that the computers that are reading this code know where one thing starts and another thing ends. I took this template and I dropped it over here into a popular JSON linting tool. And I removed one comma and one curly brace. So you can see here, it's telling me, you have an error on line 1. Somewhere in these 200 lines of code, there's a mistake, and it's up to me to go and find it. I kind of gave up. I'm going to go back and get another copy of the code. So JSON, great for computers, kind of difficult and cumbersome for humans. Now don't get me wrong, JSON, ARM templates are super reliable once you get them configured correctly. It's just not that fun to build and edit. So you can see we've got about 216 lines of code here to build our VM. Now that brings us back to Terraform. Terraform is really easy to learn and easy to edit. Here's an example of some Terraform that does the same thing, stands up a single VM inside of Azure. You might notice that most of this is comments too. So if we just look at the actual code here, it's probably around 75 lines of code versus the 216 you'll need with the Azure ARM template. Let's go ahead and get started and actually do something with Terraform. So I'll show you how easy it can be to do this. You want to log on to your Azure portal. And up at the top here, you'll see a little link for Cloud Shell. Kind of looks like a shell prompt. So we want to click on that icon, and then a terminal will pop up. Hey, look at that. Now you have a choice. You can go with Bash or PowerShell. I'm going to choose Bash today. If you've never run Cloud Shell before, it is going to ask you to create a small storage account for using your, persisting your files and your settings and whatnot. It's very affordable. This costs pennies, and if you want to see how much it costs, you can click the View Pricing button there. So we'll just quickly create some storage. I'll check the chat. Okay, everything looks good. If at any time you have trouble with the audio or have a question, just pop them in the chat and I'll take a look at the chat window from time to time. Okay, here we go. So what's happening now is a container is spinning up. So like a small Linux server preloaded with a bunch of really useful tools. So you don't need to stand up a workstation or have a fancy MacBook or any of that. You've got basically a portable Linux machine here that you could use anywhere you have a web browser. So it's got some really great tools already built in, like Git. Git is built in. All of the AZ command line tools are here. And then, of course, we have Terraform. Great. Let's go ahead and download some code that we can use to build our application. I'm going to use the git clone command for that. This is a public repo, by the way. So if you want to follow along at home, you can do so. Now we've got some Terraform code to work with. All of the files that end with TF, those are Terraform code files. So if it ends with something like disabled, that will not get read. So if you need to not run some code, just add an extra extension on the end and it won't run. Now another neat feature of the Azure portal is it's got a built-in text editor too. So you could really do everything right from within your web browser. I'm going to run the handy code command. And now I've got a text editor I can use right here. This is the main config. We put a lot of comments in here so that you can use this as a learning tool and understand what each thing is doing. The first thing we're going to try to create here is a resource group. In Azure, you have this concept of a resource group. It contains all of the stuff that you want to build. And it's sort of arbitrary. You can put anything you want in there, but you need to have a resource group to keep track of all of the things you want to build for a particular project or application. Then we go ahead and build a network, a subnet, a security group to allow traffic into our application server. It's got to have a network interface, public IP address, and then finally right down here we actually build our virtual machine. What I'm going to do next is configure a couple of variables. So this is our variables file, and these are all the default variables. I can override these defaults if I want to inside of a file called terraform.tfvars. So I'll create that file right now. We may have to refresh to get it to show up. There it is. Okay, so prefix. We're just going to call this cat app9. And host name, which will become part of our DNS record, I'll also call it cat app9. If you're doing this at home, choose a different number or a different name. Otherwise, we'll collide with one another. So I'm going to claim this name. And we're ready to go. This code is pretty simple. You only need to configure these two variables and you can run it. Our first step is Terraform init. Terraform init is going to quickly scan my code and figure out, what are we building here? What exactly is this code? And you can see it's discovered that this code is designed to run on Azure. So it can extract that. It's smart enough to understand from the code what you're trying to build. And then it downloaded the plugin, or the provider, if you will, that lets us connect to the Azure APIs. So that plugin is now stored in here. And you can see it's hidden in our .terraform directory. So Terraform has a plugin or extendable architecture. There are providers for hundreds of things, and one of our most popular providers is the Azure RM provider. So that's what we're using today. Another great feature of Cloud Shell is that I'm already authenticated too. So based on the fact that I was able to log on, I'm allowed to run Terraform commands if my account and my policies in Azure will allow that. Next step is Terraform plan. Terraform plan. you can think of a Terraform plan as a dry run. When you're building infrastructure, it's often handy to take a moment and think about what you're doing before you accidentally cause an outage. So a dry run is a great tool to be able to visualize and see what will happen when I actually push this button. What's going to happen? Terraform is reading my code, creating that handy graph that I showed you earlier. So it's mapping everything out in the correct order. And then it's going to give me a map of what it will build if I actually run Terraform. Some of this stuff we don't know yet. When we see computed, that means that we have to contact the API and that will get filled in later. So Terraform puts a placeholder here for computed. Those are the unknown unknowns. So here are our known knowns. These are actual variables that we configured. So you can see cat app is appearing in here because I set that as one of my variables. The name of my security group, the resource group name is here. Everything that we plan to build inside of the plan. And you can even save this plan for later. That's what this note here is about. If I wanted to, I could store it and then deploy the plan later tonight. We'd like to go ahead and run our plan now. So our next step is Terraform apply. Terraform is designed for safety. You do get one last chance to back out before you either build something or destroy something. And that's why it asks you to type yes. So we want to make sure you're really sure you agree that this is what you plan to do. You can override this too for automated purposes of automation. I'm going to say yes. And now Terraform is going to go ahead and quickly and efficiently build my infrastructure as code. We can even watch it building in real time if we want to. So we'll head back into the portal here and look at our resource groups. I think we called it beginners, Terraform Azure beginners. Already you can see we've built quite a bit of our infrastructure. Our resource group is here, and inside the resource group, we've got a virtual network, we've got a security group, and we have a network interface and a public IP address. Terraform is smart enough to build as much as possible in parallel. It's very efficient because it will know exactly what depends on what and build things as quickly and efficiently as possible. Down here now we can see it's reaching the end of the build. This part will take the longest. It's actually standing up a Linux server and it's going to deploy my application onto that Linux server. So we'll give this a moment to cook. While that's building, we can go back to the graph and explore it a little bit in more detail. Let me see if I can back out a bit so you can see the whole thing. Wow, look at all this stuff. So you can build these graphs pretty easily using the Terraform graph command. Where does this thing even start? You kind of want to look for this root right down here. So provider, Azure RM, the resource group really is the first thing that we have to build. So a lot of other things depend on that. You can see the virtual network needs a resource group. The security group needs a resource group. The public IP needs a resource group. And then each of those things have other stuff that depends on it. Over here we can see our virtual machine. This has a lot of dependencies. Some of them are just variables. You have to define what VM size you want, for example, or an admin password for the server. And those are represented by circles on the graph. And then the rectangles here, or ovals, if you will, the rectangle shapes are actual other pieces of infrastructure that are required to build the VM. So it wouldn't be much use without a network interface. So we build the network interface first, then we go ahead and connect it up to our virtual machine over here. All right, we're chugging right along. So the machine stood up, and now what's happening is the provisioning stage. So provisioning is how I configure my virtual machine for actual use. Terraform has this concept of provisioners. You might have a bunch of PowerShell or Bash scripts already stored, you can use those with Terraform. You can actually have Terraform run, for example, a chef recipe or an Ansible playbook or some Puppet modules you could run using Terraform. And Terraform works really well with all of these different provisioners. So you have two pieces, the Terraform for standing up the servers and the infrastructure, and then your provisioning tool of choice for actually configuring your app and building things. So the provisioner I'm using today is called remote exec. And that's just a fancy way of saying run a command. We're running a little bash script that should stand up our application and run an Apache web server. And it's given us a URL. These are the Terraform outputs. At the end of a Terraform run, you can output useful info for your users. So that might include things like this URL, a DNS record, or even just plain text where you'd like to send a message to that user who is running Terraform. Now let's click this and see what happens. Hey, we have our cat app. So this is the Meow World app. I am not a web designer. I use the very handy placekitten.com kittens as a service API. So if you'd like to play around with that, you can. They'll give you different pictures of cats that you can use on your sample application. Now let's say I'm done. I don't want to leave this application running, as cute as our little kitty is. It costs money to run that, so I'm going to do the right thing and clean up after myself with the Terraform destroy. And I'm really sure I want to destroy, so I'll force the destroy. And now we're just unwinding everything we built. Terraform is a stateful application. So another great thing about this tool is that everything I build gets tracked inside of the TF state file. You can see that in here. TF state is basically a snapshot of the last known thing that Terraform built or touched inside the infrastructure. And that state file is the source of record. So when I build a thing, later on I want to destroy or change it, fortunately Terraform's got everything recorded in my state file. I can easily go through and clean up after myself. We close the text editor, come back to our resource group, we'll see these things magically kind of just start to vanish, and then they'll all get deleted and cleaned up. So that has been a quick intro to Terraform on Azure. I'll go ahead and break here for questions. I see something in the Q&A. Okay, great. I'll repeat this. In your experience, do the Terraform modules for the major cloud providers keep updated to the same level as their native infrastructure as code tools? For example, ARM templates, AWS CloudFormation, etc. Is the module updated promptly after the cloud provider updates their APIs? That's often the question execs tend to ask while selecting an orchestration system other than by the native cloud orchestrator. So it's a valid question. Basically what they're saying here is, I'm nervous about using some external tool on Azure. You know, the Microsoft one is approved and it's always going to support whatever they have built. The short answer to your question is that we work very closely with all three of actually all of the major large cloud providers, but definitely the big 3 or 4, to keep Terraform very, very closely up to date. So sometimes you'll have day 0 support for a new feature, and that just often depends on the team inside of the cloud provider. Terraform is in huge use inside of Azure, AWS, GCP, and so sometimes there is a little delay, but I've never seen it be more than a few weeks or a couple months at the most. So if you plan carefully, it's not often you have to use a feature the same day it's launched. If you do, power to you, right? If you're able to use a new cloud feature on day 1, that's great. Sometimes there will be a little lag, though, between the day it's launched and when Terraform, supports it. But eventually, we will support that feature. All right. So next question I see in the chat here: does Terraform support adding variables at the command line? And the answer is yes, it absolutely does. So you saw one way of defining variables in my file. You can define them in a file, but you can also use a variables flag and even override that file. So if you need to just run a quick Terraform command on the command line, either manually or through some sort of an automated system, you can define Terraform variables on the command line. The third place you can put variables is into environment variables. So these are the OS variables that kind of live along with your Bash or PowerShell or Windows session and can be used by applications who can read environment or system variables. All right, next question I see is, can you talk about Terraform workspaces? No, unfortunately, not during this webinar, but I can give you a link you can go to. So just go look for Terraform Enterprise. There's a whole bunch of stuff about workspaces. If you'd like to email me privately, I'll be happy to give you some more resources. Basically, workspaces are an enterprise feature that we just don't have time to get into today. Next question is there any way to manage secrets in Terraform? Yes. In fact, we happen to have a secrets management tool. You might have heard of it. It's called HashiCorp Vault. Vault is a secrets management system for on-prem or cloud. And like all of our tools, they work really well together. You can use the Terraform Vault provider to fetch secrets at runtime so that you're not storing sensitive data like usernames and passwords in plain text. So Vault, also open source. You can use it for free, and it works really well with Terraform. Check the Q&A. Okay, here's another one. I just had a long day with Terraform. Well, I hope that's a good thing. I wanted to ask about null resource and running local exec before creating the resource. Okay, this seems like a little bit more of a rabbit hole than we have time to get into, anonymous viewer, but reach out to me. I'm just Sean at HashiCorp.com. So if you want to email me, it's sean@HashiCorp.com. And I'll go into null resource and local exec with you. And I think we may have time for one or two more questions. Here's a good one. Can I run a specific Terraform file rather than all the TF files in my directory? The answer is no, you can't. It is by design. We've kept it pretty simple. If you'd like to just run one Terraform file, put it in its own directory or copy it to its own directory and run it there. Part of the reason for that is that Terraform by design will collect all of the stuff inside of all of the TF files and then create one state file. And what we don't want to do is create a state file that is sort of weird because it was only generated from one TF file, and that could create inconsistencies. It could break things. So the safest bet there in your scenario is just stick your TF file in its own directory and run it from there. Okay, I'm seeing a comment that's saying you can use target. Yeah, that's very possible. Definitely. Place your state file in the same TF folder. Okay, I will stick around and hang out in the chat if you guys want to talk about that some more. But we are just about at the hour, so I'm going to hand it back over to Katie. Thank you very much for your time.
Thanks, Sean.